Hello, everyone. Good evening once again. My name is Hari. I'm the admissions director for the postgraduate program in machine learning at Great Lakes Institute of Management. And today we are here to talk about machine learning at large. Right? What is the industry outlook? What is driving the demand? What really is changing in the world around us? Why is learning machine learning so important and so career critical in today's time and age? And of course, we'll also talk about the program at Great Lakes, which is the postgraduate program in machine learning, and how the program can set you up for a fantastic career in machine learning. So before we get started, first of all, thank you so much for joining me on a weekday evening. It's fantastic to have you all. It also shows the kind of interest that you have exhibited in wanting to learn machine learning, and that kind of dedication is great to see. My name is Hari, and I head admissions at Great Lakes for our programs in AI and machine learning. And the way I have structured this session is that the first part of this session is going to be more about the external world and why is machine learning becoming so important for businesses and thereby for professionals like us. And the second part is going to be about the postgraduate program in machine learning by Great Lakes, and a basic primer information about it, and what are the aspects that differentiate the program, and really make it a unique learning experience for all who participate in it. At any point in time, when you have questions, feel free to type them in, and towards the end of the session, we'll go through the questions, and my effort would be to help answer every question that you have. So I'm sure that by now all of us have heard about machine learning multiple times in a day. Right? If you open any newspaper, you look at your news feed, or any news app, it is inevitable that you will find some impact, some advancement of machine learning, AI, deep learning, data science being spoken on a regular basis. So, what really is the fuss all about? Let's start with the bigger picture here. So, if you look at what NASSCOM has to say, so NASSCOM predicts that machine learning and data science as a sector in India is likely to witness an eightfold growth, and it is likely to get to 16 billion by 2025 and is currently at about 2 billion, right? So we are talking of an 8x growth in 7 years, right? And honestly, I can't think of any other sector that is growing at that rapid a pace. McKinsey believes that India is all set to become one of the top two markets for machine learning by 2020 in the world. And similarly, a study by Kaggle shows that 50% of data scientists and machine learning engineers have a post-graduation degree. So that also goes to show that if you are serious about learning or building a career in machine learning and associated fields such as AI and deep learning and so on, then you have to pursue the education in a more serious format. Right? You cannot be superficial. You cannot be scratching the surface. This is a proper field of study that requires time, effort, dedication, and when you show that diligence in learning is really when you get the impact that your career really deserves. There was a study recently by Deloitte on the impact of machine learning, and it was really very telling. So what Deloitte reported is that in the first 5 months of 2018, the number of machine learning pilots and implementations that have happened by companies is already double than all of what happened in 2017. Right? So what is clearly visible is that there has been a rapid increase in the way companies have adopted machine learning techniques and are using machine learning on a day-to-day basis. Similarly, the report also suggests that by 2020, the number of pilots and number of implementations are likely to be double of that of 2018. So you can see it's not just one rapid increase that's happened, but it's also about how that is going to be sustained. and how this is an area that is generating so much more demand with every passing year. Same is the case if you look at the spending forecast. So in 2017, companies spent about $12 billion in machine learning, and by 2021, that is likely to increase 5x to close to about $60 billion. Again, spending always shows that the market is growing. If there is going to be a 5x increase in spending, it only means that there will be a commensurate increase in the number of jobs, in the salaries that professionals demand, in the number of professionals that are needed by the industry. Like, all of these are indicators of a great opportunity that lies ahead for everybody who wants to learn machine learning and be skilled at it. One of the most interesting aspects that came out in this study was that when asked as to what really has held companies back from implementing machine learning at an even faster scale, the biggest reason stated is the lack of talent. Right? So the first and foremost reason stated by most companies is that they are not able to do more with machine learning because they are not able to find the right talent. And that is an amazing place to be in as a trained professional. So if today, if you are well-trained, proficient, and competent in machine learning, then you are actually in a scenario, your career is in a scenario where the industry is growing, or the industry is likely to grow 5x in the next 3 to 4 years. And at the same time, companies are struggling to find talent, right? So you have this wonderful career arbitrage playing in your favor. So the lack of opportunities is not going to be a reason for you to break into machine learning. It will all come down to how competent and proficient you are in applying machine learning techniques to solve problems. And as we talk more about the industry that's growing and the demand that's increasing, I'm sure many of you have this thought in terms of what really is the industry outlook in terms of jobs and careers. So what is clearly seen is that if you compare, a professional with similar years of experience at, in IT as compared to machine learning, we are seeing that on an average, professionals who are working in machine learning or machine learning jobs or roles are on an average being paid 50% higher than their counterparts in IT careers. And this data point is actually very consistent with our own career transitions of alumni and candidates that we have seen in our programs, and that also is close to 50%. NASSCOM believes that there is going to be a shortfall of 100,000 machine learning engineers and data scientists in India by end of 2018. So clearly, there is no way that this gap is going to get bridged. But look at the immense potential that lies ahead. And while the potential is large, professionals who move early, move fast, always have the first mover advantage. And that early advantage can actually be a big differentiator in terms of how your career gets built over the next decade or so. Within our own extended corporate network and our corporate outreach, we have seen that there are about 600 data science firms in India that are looking actively to hire professionals in machine learning. In fact, if you just research on LinkedIn, you will see that only in a place like Bangalore, in the last 30 days, companies have posted close to 4,500 new jobs across machine learning, data science, and AI. Right, so that is the kind of demand, and I'm talking only about last 30 days in Bangalore. Right now, obviously, if you expand that to overall India and so on, that number is much larger. But that is the kind of demand that is coming in, and that is the kind of opportunities that as professionals we all can have if we upskill ourselves in this area. When we look at the kind of companies that our own candidates have transitioned into, it presents a very interesting picture. So typically, a lot of professionals think that, when you talk of areas like machine learning or careers in machine learning and associated fields, data science and AI and so on, a lot of candidates feel that, well, this is the bastion of technology companies. So, machine learning engineers are probably needed only at Googles and Facebooks and Amazons of the world. While it is true that these companies are recruiting, and our own alumni have made transitions to such marquee names such as Amazons and Googles and Microsofts of the world, but the opportunity set in machine learning is not constrained only to such companies. As you can see in this grid that is being shown to you, you can see that alumni have transitioned to a range of organizations, right from marquee tech companies to consulting companies, uh, to data science consulting companies such as Fractal and Mu Sigma, to management consulting companies such as Deloitte and EY and KPMG and McKinsey, to banks such as HDFC and Citibank and Bank of America, to technology services companies such as Cognizant. So there is a range of organizations that are now using machine learning, and as professionals, these are all companies where you can actually build a really successful career. So the addendum question here is, what kind of roles really exist in machine learning? I just got a ping about the level of voice, the level of audio. I hope you all can hear me. If any of you are having a trouble, please do drop in a message to the chat window, and let's continue. So, what kind of roles really exist in machine learning? Well, we all have heard the term data scientist, right? So that is a common role that exists across companies, across industries. But typically, when you start off your career, or let's say in the less than 5 years segment, you start off as a data engineer or a data analyst or a business analyst or a machine learning engineer, right? So these are the roles where you begin. And then to go up the ladder with more exposure and more experience, you can then get into consulting roles. There are a lot of consulting roles that require candidates to be proficient in machine learning, or you could go into more solutioning roles, like a solutioning engineer and so on. And there is, of course, the whole architect track where you can be an AI architect or a machine learning architect or a data architect, technology architect, software architect. These are all the various designations that exist. And beyond that, of course, you have leadership positions, and on a parallel track you have the entire data scientist track, right, where in some companies take in candidates as a junior data scientist and then train them into more data scientists and so on. So there are different roles. It's not as if companies all follow the same nomenclature, so as to say. So there's a whole host of roles that you can graduate into, and it all depend upon what level of experience you are in. And one of the common questions that I get at this point is that, I have 7 years of experience in IT, and once I learn this, am I going to start off again as a fresher? So that is not always the case. Let me be very clear about it. In fact, we have seen so many of our alumni, who transition into related roles, right? So it is not as if people with 7, 8, 9 years of experience then give up all of that experience and they come back and start as a fresher. So that it's not as if that happens, right? For a lot of these candidates, they actually move into roles that recognize their experience. And the reason for that is very simple. The reason is that companies are essentially at this point in time looking to bring talent on board. So if they see that, somebody is talented and somebody can be a good fit, then the entire negotiation for that role is actually in your favor, because companies at the first point are struggling to fill in these roles, right? And that is why we see transitions across the board, even at experience levels, and people really don't forego all of that experience to start off as a fresher. I thought it would also be a good idea to dig one level deeper and understand some of the terms in machine learning. I'm sure some of you would have come across these terms before. So machine learning is broadly broken down into two subsets: supervised learning and unsupervised learning. Supervised learning is further broken down into two most common techniques known as classification and regression, and unsupervised learning, one of the most common techniques, is clustering. So let's in very layman terms try and understand what these buckets are and what these techniques are. So let's start with supervised learning. So supervised learning is essentially where you are training the algorithm by giving it an input data set and asking it to predict what the output is going to be like. But one step before that, in fact, even before we go into supervised and unsupervised, let's take a step back and understand what is machine learning in the first place. So machine learning is all about developing algorithms that get better at performing a certain task as more and more data is fed into them. Right? So essentially, in many ways, you are building systems that help machines to learn over a period of time. And how do machines learn over a period of time? By working on more and more data, to the extent that they get so much better that they pass, or at times they even supersede accuracy levels done by human beings on those tasks. And we can take some examples. So let's say when we talk of supervised learning, so what I tried to explain to you guys in supervised learning is that it's an example where you have input data, which is known as the training data, and you are training the algorithm to look at patterns and figure out what the output is going to be like. Image recognition is one of the most common examples of supervised learning. Whether it is about training an algorithm to identify colors on cards, or even if it is as complicated as doing facial recognition, right? So for all Facebook users, you would have seen that you upload pictures and Facebook detects whose image it is. That is one of the most successful applications of machine learning that you can see in our daily lives. And it is completely built on this. So earlier, when Facebook's algorithm, which is called deepfakes, was not able to do that, you were tagging people saying that, okay, this is the picture of my friend, this is my family, so on and so forth. And by tagging, what you were really doing is that you were training the algorithm until it got to a point that it's actually gotten very, very good at identifying people from images. Similarly, unsupervised learning is the other broad category of machine learning where there is no training data set, where it is not as if you are feeding a set of data and training the algorithm. But unsupervised learning is a broad set where you are using techniques and devising the algorithm in such a way that based on logic, the algorithm is able to cluster and classify items, people, units into meaningful groups. One very common example of unsupervised learning that we all have experienced is on e-commerce sites. So when you look at, when you are trying to buy anything online, and you would see that whether it is an Amazon or a Flipkart, it would tell you that you may also like these set of products, or others like you have also bought these kind of products. I'm sure those are panels that we all are familiar with, and that is a technique that is known as recommender systems, right? And it was pioneered by Amazon, but today it is used across the board. In fact, in the program, one of the projects you will be doing is to build a recommender system, right? And today, any e-commerce site you look at, any travel site you look at, any Netflix is another example which uses recommendations in a big way. Almost any consumer internet company you look at, based on your data and your preferences, it will recommend that you may also like to do these things, or you may also like to buy these things, right? So that is a classic example of unsupervised learning. On a related note, one of the common questions that get asked is, what is the difference between deep learning and machine learning and artificial intelligence? First and foremost, it is not about the differences. What we have to realize is that these are actually highly interconnected fields. They are not they are not really separated and distinct from one another. One leads to the other. And let me spend some time to help you understand this. So as we spoke about machine learning, like machine learning is about developing algorithm systems and machines in such a way that they are able to, first of all, they get better with time as more and more data gets processed, and over a course of time, they are able to do things in a more accurate and predictable and consistent fashion. Right? That is the underlying logic of machine learning, and it's a confluence of computer sciences, of data science, of problem solving, and so on. Now, what is AI then? AI is basically the broad field where you are working on making machines think like humans or take decisions like humans. A good way or a very simplified way of understanding the difference usually is that in machine learning, you are actually trying to train your algorithm or build an algorithm that becomes very good at doing one thing. So if it is recommendation systems, that algorithm is extremely good at doing that. If it is image recognition, then that algorithm is extremely good at doing that. Whereas that's not how the human brain works. When you talk of the human brain, it is not only one thing that you're getting good at. Right? There is always a context, and there are always interdependencies. There are always adjacent tasks and things to do. So when you start training your algorithms and when you build your algorithms in such a way that you don't only focus on one aspect and do that really well, but you are also able to execute or solve problems in adjacent fields, that is when you are actually entering into the area of artificial intelligence. An example to this could be an example that we all would be able to relate to is any voice assistant, whether it is an Alexa or a Google Smart Assistant or a Siri. Now, if you think of your interactions with the voice assistant, it is not as if every day morning you wake up and you ask the same question, that what is the weather today? If that is the case, then that is firmly in the field of machine learning. But that's not how it happens, right? You wake up, you'll ask about the weather, then you may go into what's the score in the cricket match, then you may ask the assistant to play some music that you like, right? So you are essentially giving it a series of tasks that have adjacencies, right? And now when you build that algorithm, you have to enable the algorithm to think and process information like the human brain, so to imitate the human brain, and that is what AI is all about. And the dependency between machine learning and AI is that machine learning is one way of implementing AI. The corollary question here could be that, can you do AI without machine learning? Theoretically, yes, you can do AI without machine learning. But the amount of effort in terms of lines of code that you will have to write and maintain, and the kind of complexity that you will end up building, is unmanageable and non-scalable. Which is why there is practically no company in the world that implements AI without machine learning. So, so hence, when you try to think of these areas, what you should always remember is that machine learning leads to artificial intelligence. Right? They don't really work in isolation. There is no AI project which won't start without machine learning. So you first have to build solutions using ML concepts, and then on top of that is when you build, starting using deep learning or NLP or vision and so on, right? Which is the enhancement you do right? To go into, as we spoke, into more complex decision making systems. Similarly, deep learning is another way of implementing AI, which is built on machine learning, where it is all about neural networks, where it is all about building logic in such a way, the way human brain thinks. But there also, most often the problems start by implementing solutions on machine learning. So that is the whole interconnectedness between AI, machine learning, and deep learning. And the important point to understand here is that one leads into the other, that one feeds into the other, right? It is so even if you finally your goal is to become an AI engineer or an AI scientist, you have to start with machine learning. There is no other workaround to it, right? You can't directly jump into deep learning, or you can't directly jump into AI and NLP, because that's not how organizations implement these things. If you look at the world around us, the impact that's happening, the kind of change that is coming about, what you would realize is that the core of this change, the crux of what is really moving the needle here, is data. Why has machine learning suddenly become so important or career critical? Are machine learning techniques really an invention of the past 10 years? Is AI something that was developed in the last 5 years? It's hardly so. The first set of research and applications of whether it is machine learning or AI comes right from the 40s and 50s. In fact, I'm sure all of us in our engineering days have heard about Alan Turing. Alan Turing used to work during, in the World War II era, right? Where he, and further on, he went on to build the Turing machine, which was one of the first implementations of this. So none of this is new from a theoretical standpoint. What has really changed in the last 5 to 7 years is that its applications have immensely increased. And why have those applications increased? Because in the last 5 to 7 years, what has really happened is that the volume of data that organizations are tracking and sitting on has gone through the roof. We are in the midst of a data revolution where companies today are sitting on large volumes of data, are processing data faster than ever before, are having more capable resources to mine data, and it is becoming cheaper to understand or to process data. These are the auxiliary factors that are driving the data revolution, which is why organizations today have to be more sophisticated in the way they deal with data, in the way they infer information from data. And that is the primary reason why machine learning or there is such a huge boom for professionals in machine learning. In this infographic that you can see on your screen, you will see how the data revolution has come about. If you recollect, in the early 2000s and the late 90s, there was huge demand for business intelligence. BI was really powering a lot of companies, and that was also on the basis of data. But the difference was that BI was primarily about reporting, was primarily about using data to showcase or to communicate what has happened in the past. And that was the entire domain of BI. By around 2010 onwards, companies started using the same data to actually build models to predict what is likely to happen. And that was the entire realm of analytics and predictive modeling, and that's something that a lot of companies do even today. Then by about 2014, 2015, what happened is that the volume of data and the whole nature of data, the kind of variety of data between structured and unstructured and so on, started increasing so rapidly that companies had to build more sophisticated technical technology infrastructure to deal with this kind of data, to be able to process this data and run models on it or build models on it. And that was the entire advent of data science and big data. In the last 12 months, many of the companies are now progressing into using the same data science models into implementing or doing pilots and implementations around machine learning. That how do you build a model that not just helps you infer a solution, but also gets better at performing a task over a period of time. And the next frontier from machine learning is AI and deep learning. That how do you actually use data to solve contextual questions in business, to solve interconnected problems, to solve interdependent problems. And that is where AI and deep learning has to work. So what is important to understand is that this is the data revolution, that irrespective of what scale of organization you are, whether you are a startup or whether you are a Fortune 100 company, in today's time and age, it is inevitable that you will be at some point in this graph. And most companies today are in the data science and beyond category. And once you are at one stage, as your models achieve maturity and adoption increases, you will progress to the next stage, right? So this is a journey that all organizations will chart, and that is why there is a huge future for professionals who are getting trained in machine learning. So I guess with those examples and with understanding of what the industry is really looking for and what is the whole data revolution as we're talking about, I'm sure many of you are curious that, okay, there's something I'd like to do, but what is it that you really need to break into roles in machine learning? So to start with, the skills that you need to have is that you should have good quantitative skills, because the core of machine learning and data science is statistics. You don't have to be a maths Olympiadian, you don't have to be a statistician, you need not have scored straight hundreds in your 10th and 12th. Those are not the requirements. When you say quantitative skills, it is essentially the ability to work with numbers. At least you definitely cannot be scared of it. The other is some knowledge on programming will help. You don't have to be a programmer, right? It is not as if machine learning roles are open only for people with hardcore programming experience. That's not the case. But having said that, any kind of programming, whether you have learned that in school or college, irrespective of what language, it could be in C, C++, Java, whatever that language is, as long as you have a functional knowledge of programming, that helps a lot, because it makes it easier for you to learn Python. And Python today is ranked as the easiest language to learn, by the way. There are so many professionals who learn Python without any base in programming, right? So that is something that is really easy to learn and to implement machine learning, which is the reason why it's growing in prominence. But at the same time, if you have some basis in programming concepts, that will help. The third, which is really important, is that ultimately when you work in this field of machine learning and AI and deep learning, you will encounter a lot of problems. You actually have to have a problem solving aptitude and approach, because that is what will help you really crack tough problems. Then of course you have to be willing to reinvest and keep learning, because this entire field is evolving. There are newer applications that are coming out every month. So you have to be prepared to be on a constant lookout to how can you learn better. And finally, it is about what are you what really are you inferring from all the data that's coming your way, right? It is not about how sophisticated your machine learning model is. It is not about how complicated your tool infrastructure is. It finally all is about how effectively have you solved a business problem using machine learning techniques. And to make this transition and to bridge this gap, the way you will essentially have to learn is that you have to build your foundations in statistics. That is where it all begins. And then you have to go on to, equip yourself with machine learning techniques and its applications. This is extremely important, right? It is not enough to know what regression is. It is not enough to know what a recommender system can do. What you really need to know is how do you build a recommender system? What kind of problems does it solve? What are its limitations and pitfalls? What can it really do? What kind of data needs to go into that model? That is the kind of practical insight and application that the industry looks for. Because when you go into the industry, your job is not to be a theoretician, right? That is not why they are hiring you. They are hiring you so that you can go and solve problems. And you will get there only when you understand conceptual understanding, or when you have conceptual understanding. But when that is led by application, when you solve a lot of problems using these techniques. And then, of course, as you try to solve problems, what will be important is that you become proficient in one tool. And Python is the tool of preference when it comes to machine learning and AI. So you learn that one tool and be really good at it. Again, you don't have to be a Python programmer. The idea is not to learn the entire expanse and scope of Python. The idea is that you learn enough to be able to implement machine learning applications on Python. So that is a few libraries, a few function calls, and you know what to do when. All right, so that was the first part, which was all about what is the industry looking for, what really is the huge scope and demand for machine learning, and how can professionals bridge this gap and make a career in it. The second part is a brief overview, a quick walkthrough of the postgraduate program in machine learning and answering some of the most common questions that come my way. And I'm sure once I'm through this, some of your questions about the program would also have been answered. To start with, the postgraduate program in machine learning is a 6-month executive program for working professionals. It is designed exclusively for professionals who are interested in acquiring skill sets in machine learning. It's a blended format, which means it involves classroom sessions, weekend classroom sessions, as well as online learning with a lot of lab support and hands-on work. Great Lakes, of course, is industry recognized for its standing in analytics and data science education. Our business analytics program that we started with is now ranked number 1 for 3 years in a row. And the postgraduate program in machine learning, is a dual certified program, which means you get a certificate not just from Great Lakes, but also from Stuart School of Business. What really makes this course unique? Broadly, 3 aspects. The first aspect that really makes the course stand out is its immense focus on being hands-on. And that is something that really makes a difference, because, as I was saying, you not only learn theory, but you also learn the ability to apply these to problems. And that is extremely helpful. To the effect that what happens is, because you work on multiple projects in the program, by the time you end the program, what we also build for you is a portfolio of projects. And this portfolio of projects is something I'll talk about in a few slides from now as well. Is showcasing your entire exposure to machine learning domain, the different kind of problems you've solved, what kind of skill sets you use, and these play an extremely important role when it comes to cracking a job interview. Similarly, on the hands-on part, the other factor that really makes the program stand out is the extensive lab work that happens. So every time you come for classroom sessions, there will be lab work that will be there, and there will be designated lab hours and sessions that you'll have to do, and that further gives you the a lot of problems to solve, such that you focus on practice and more practice. The second aspect that differentiates the program is all about industry. And the teaching in the program is such that you learn both from academia as well as industry. So we've picked out some of our most senior faculty in data science and machine learning. And at Great Lakes, 3 of our faculty have been ranked amongst the top 20 data science academicians in the country. So some of these very senior and very proficient faculty come and teach you, but beyond that, there is a lot of industry professionals who come and teach. And again, the kind of problems you solve are all mapped to industry requirements. The other aspect of industry focus that comes in is the capstone project. The capstone project is entirely a real world industry like problem that you're solving, and you solve it the entire 9 yards. The third aspect that distinguishes the program is its focus on being current and contemporary. So what you are learning is essentially what is being done today by the industry, right? We continuously refresh the curriculum every 6 months to ensure that your skills that you're acquiring in the program are in sync with the requirements of the industry. And the big benefit, of course, of the postgraduate program in machine learning is the classroom component part of it. See, it's important to understand that learning any skill is a tough effort. But when it comes to learning advanced skills such as machine learning, the more support and guidance and personal attention that you can get, the better off you are. And which is what we have been able to achieve by putting in classroom learning and postgraduate program in machine learning. So you will learn in person from faculty and industry guests. The faculty and industry guests are right there in the classroom to solve your doubts instantaneously, to give you the personal attention that you need, which is not the case when it comes to an online learning program. Similarly, we also have program specialists and subject matter experts who help you in class with your lab sessions. These are again technical experts who are who will support you and help you solve your problems, right? So again, guidance is available, at all times, so that you get that personal mentorship. And the third aspect, of course, is that because you're learning in a group with peers from other industries and other leading companies, the kind of networking and connections that you're able to build with your batchmates, with your faculty, with your industry guests, actually have a massive advantage for you. And that should always be one of the highlights for any executive program. So program on program, we have seen that through our classroom programs, there are job opportunities that get shared. We have seen senior candidates actually recruiting candidates from the batch. We've seen our industry guests opening up job opportunities, handpicking candidates for their projects. All of these things happen because you are there in person, learning with others, learning from experts. And our stats validate the success of this format. So for the program, for the PGP-ML program, our average student feedback rating is 4.65 plus on 5, and we have 90% completion rates. This in an age where it is hard for people to focus for more than 3 minutes. Right? Imagine this is the kind of feedback that's happening when attention spans of people are decreasing with every passing year, right? And then to ensure that they learn machine learning and they are satisfied and delighted learners, obviously means that the format and the learning experience they undergo has a huge role to play when it comes to their success. I do have a few questions popping up on my screen. What I would honestly request is to just hold on. I mean, you can keep typing your questions. That's not a problem at all. We are going to take up all questions as we approach the end, right? So I'll make sure that you all have your questions answered. Another common question could be that, what are you going to learn in the program? Right? Machine learning is a vast field, and what really is the focus of learning? So the way the program curriculum is structured is that there are four interconnected streams of learning. It begins with data science foundation and Python, then it goes into supervised learning, then unsupervised learning, and finally it caps off with introduction to deep learning. So these are the four broad modules that get covered in the program. And to take a deeper look at it, this is how it goes. So when you come in, the first month is a foundation module month where you learn data science foundations, you learn basics of statistics, Python, hypothesis testing, and probability. And this roughly actually goes for about 2 months. From the third month to the fifth month is where you learn supervised learning, ensemble techniques, unsupervised learning, featureization, and recommendation systems. And the sixth month is where when you are introduced to deep learning. That will be an introduction to deep learning, neural networks, keras, and TensorFlow. So the bulk of the program focuses on machine learning technique and its applications. Every time when you come for classroom sessions, there will be lab exercises that you'll have to do. There will be lab assignments that you'll have to do. There will be dedicated lab support with our subject matter experts who will help you solve problems while you're there. And there, of course, will be take-home assignments as well. And between one, classroom session to the other, or between 1 month to the next, your entire focus will be on revising what you have learned, doing assignments and projects, and coming prepared for the next session, right? So there's a lot of learning content that gets shared that you have to go back and revise and do more of assignments and projects for your grades and better understanding of concepts, and also cover all the pre-reading material for your upcoming session. That is the way that you are completely glued in and tied into the program. And it is not as if you come attend a session and then you switch off and come back again. That's not how it works. You will be doing multiple projects in the program, which will finally also finish off with a capstone project, which is a full-blown machine learning project. Most of these courses are taught through case studies, so you will actually not just be learning theory, but actually learning the applications and problem-solving part of it. In Python, of course, when it comes to libraries, you will be focusing on NumPy and Pandas and MLlib, and you'll also be given an introduction to keras and TensorFlow. Projects, as I have spoken about, are an extremely important part of the entire learning experience, because this is what really differentiates you from other candidates who are learning machine learning from a very superficial standpoint, right? Because here is your ability to stand out by doing more and showcasing more. And as you learn in the program, we build out a portfolio, a shareable portfolio, an e-portfolio for you, which is verified by Great Lakes, and you can share with all your recruiters. And it goes on to show all the projects you've done and what kind of skills you have gained as a means of doing that project. And from the several of our alumni who have successfully transitioned their careers, what we are getting to hear is that the project portfolio, the e-portfolio, plays a crucial part in them converting and getting that job. Because if you think of it, when a recruiter looks at a portfolio, they are bound to ask you questions on that. And that has to be a strong point, because these are the projects you've done. And if you can, really form an impression on the depth and clarity of concepts exhibited through those projects, then your battle is half won already. And some of the kind of projects that really happen, I've mentioned that there is a project on taxi demand, which also uses Uber data. There is a project on customer sentiment from Amazon reviews. There's a project on recommendation systems using your music streaming service. There's a project on visualizing how art sales at an e-commerce site works. So all of these projects are extremely industry oriented, and they are not theoretical at all in nature. So after hearing all of this, how do you know if this is the right program for you? So first of all, the prerequisites is that you need to have a bachelor's degree. You should have at least 2 years of professional experience. You should be familiar with high school mathematics, so you should have a quantitative mindset. And you should have some functional programming knowledge. You don't have to be a programmer, as I told you before. As long as you understand syntax, function calls, procedures, that is all that is needed. Because with that, learning Python is one of the easiest languages that you can learn. And any language is fine. Any exposure to any programming language, whether it is C, C++, Java, whatever it be, it's fine as long as you have some functional exposure. And for all admitted candidates, who don't know Python, what we do is we share a pre-programmed tutorial, right, that actually helps you come up to speed. And even once you are in the program, in the foundation module, we begin with basics of Python itself. So there's a lot of support that is provided to you. So you should, this program can really do wonders for you if you're a professional who's serious about moving into machine learning. Or if you were already working or just started in big data or data science and want to gain an in-depth understanding, because as we saw in that data revolution infographic, after data science, the next hoop to cross is machine learning. And finally, you are a great fit for the program if you're ready to learn by solving problems and doing a lot of applications. The corollary here is who should not pursue this program. So if you are not anyway, or if you don't want to play any role with technology or machine learning, then this is not the right program for you. If you want only a high level business overview, if you just want to know, okay, what are the 5 techniques in machine learning, but you don't want any depth into how these techniques are applicable or how problems are solved, then this program is an overkill for you. If you are only focused on learning Python and you don't want to learn anything beyond, if you want to be a Python programmer, then this is not the right program for you, right? Through the program, we are not creating Python programmers, we are creating machine learning professionals who can use Python. Another very common query, and I'm sure many of you have this in your mind, is what about placement assistance? So we do have a full-blown, career services module where we conduct career development workshops. We do a lot of industry connect, a lot of alumni connect for mentorship. So if you are from a certain domain and if you're looking to build or transition, we will connect you to alumni like you who have done that, who can mentor you, who can guide you on what should you be doing. A lot of peer-to-peer networking and industry networking that we do. I've spoken about the e-portfolio that gets created that gives you a real shot at converting interviews. And finally, what we also focus a lot on is getting you more and more opportunities. So we have a very active job board in the program which gets refreshed on a fortnightly basis, where we keep posting new opportunities. And as a learner in the program, you will have access to all these opportunities and you will know which are the companies that are recruiting, and you can apply to the ones that you think you're a good fit for. Once you apply, then your profile is directly shared and the process happens between you and the recruiting company. So that's how that works, and that is an area of immense focus. It also gives you an edge in terms of standing out and getting more access to opportunities. Overall, we've been sharing 100 plus opportunities every month, and we have seen that 2 in 3 of our candidates and alumni achieve career growth and transition. And with an average salary hike of about 35 to 40%, it goes all the way up to 80-90% also, but average it's about close to 40%. Just in the last 2 weeks, if I look at the transitions that have been populated, you can see that there are people who moved from engineering roles in Cognizant to data science roles in Latent View. Similarly, somebody who was a tech consultant has moved into analytics subject matter expert at Shell. A software engineer at Capgemini has moved into data engineer at TransUnion. Senior business analyst at Omni Group to manage a strategy. That's a case of promotion that happened. A business analyst from Ninja Cart has become a senior business analyst at Deloitte. Similarly, manager to AVP levels and consultant to data architect levels. These are just some of the ones that have happened in the last 10 days or so. But this is a constant thread that you will see across the program. And today, when you look at where all our alumni work in data science and machine learning roles, you will see that the grid is a distribution across a range of companies, from technology to e-commerce to banking to engineering to manufacturing to telecom to retail to oil and gas and whatnot. And that just showcases that two things. First of all, if you are from any of these industries, this is the biggest evidence of the fact that machine learning is happening in that right here, right now. And because there are alumni working in these companies, there will always be a scope of mentorship and guidance for you to build your career in those areas. And secondly, the other aspect is that today machine learning is not restricted to any one industry at all. So, as long as you are well trained and you are proficient in application of machine learning to solve business problems, you will not be constrained by the kind of companies, the kind of opportunities, right? The opportunity canvas out there is immense, and it is all about whether you are a good fit, the right fit for those roles. So that kind of brings me to the end of what I had to share, and let me quickly jump into the questions that have come my way. So there are a bunch of questions around duration of the course. So the duration of the PGP-ML
All right, so I have a few questions here, and let me start taking them. First question I have is from Dr. Mohammed Akhtar. You want to know the difference between statistical learning and machine learning. So statistical learning is more about application of statistics. So it is basically, the statistical foundations, and statistical foundations are the core to machine learning. Except that in machine learning, you also use advanced concepts because you're also training an algorithm. So it is not just mathematical, but you're also training an algorithm, training a machine to perform a certain task better. Whereas statistical learning is more, or the basic core concepts of statistics is all around observations, right? That you make when you have data to understand the patterns in data. Whereas machine learning builds on top of that. It's not just about observing what the data has to tell you, but it is also about how do you design systems, machines, and algorithms, to do certain tasks certain tasks at a higher accuracy with a lesser cost and complexity, and in such a way that as those algorithms are fed with more and more data, they only get better with time in terms of accuracy. Similar question from Senthil Raj is, how does machine learning differ from data scientists and data? The question is not entirely clear, but maybe data analysis is what you mean. So data analysis again, Senthil Raj, as I was trying to explain to the other candidate, is a lot around analyzing data and finding patterns and making observations about what the data has to tell you. Data science and machine learning, on the other hand, are very, very closely related. In today, for example, you cannot be a data scientist if you don't know machine learning. Right? Data science is a broad category which involves data engineering, machine learning, sometimes even AI, and so on. It varies from company to company. So data science and machine learning are closely related, are interchangeably used. Data analysis is usually one step before that. There are also questions around courses in machine learning, subjects in machine learning. I think that is something that we have already covered in terms of supervised, unsupervised, ensemble techniques, and so on. Gaurav, your question is around career assistance and domain knowledge. So I think career assistance I've spoken about. In terms of domain knowledge, does that help? Absolutely, because what is important to understand is that we saw with that grid of companies that today machine learning is applied across a variety of organizations in different sectors. So it is not specific or restricted only to, let's say, technology companies, right? We are seeing automobile companies apply machine learning and hire from us. We're seeing pharma and healthcare companies, uh, FMCG companies, all of these, right? Because they all are sitting on large volumes of data. So domain knowledge helps because ultimately using machine learning and data science, you're finally solving a business problem. And when business problems have to be solved, there is definitely a premium on the kind of domain understanding you have because problems have to be solved in a certain context. And and that is always good to have. Arunachalam, you are curious to understand the distribution of students like years of experience. I think that is something that you should reach out to the admissions team. They will be able to guide you with all the information on that front. In fact, I also see a bunch of other questions around admissions in terms of batch starts, how, when does the admissions close, when can you apply. I think all of these questions I would suggest please route it to the admissions team and they will provide an immediate resolution for you. Overall, in terms of average experience, what we see is that there is an experience spread between 3 to 20 years, and the average experience is close to 8 years. Again, question from Arunachalam, do you need to know Python? You don't need to know Python because we teach Python right from the very basics. Any exposure to programming language is definitely an added advantage because that'll help you. It'll make it easier. Any language is absolutely fine. But when it comes to Python, we start from basics, and in fact, even before you start your program, you would be enrolled into a prep course on Python fundamentals. I have a few questions around whether AI would be covered in the program. So AI is an extension of this program. So there are candidates who do only the 6 month machine learning part, and there are other candidates who continue to do another 6 months in AI, and that's the choice that you have. Sumit, your question is that do you have to have worked in big data analytics for a role in ML? I don't think that's the case, Sumit. In fact, if you look at our students and even our alumni, you would see that prior to the program, only about 20% of them have had any exposure to analytics, right? Most of them don't have prior exposure to analytics, but they do come and learn and they are able to transition. Raman, question from you that, if you are in a leadership role, would this help? I think it's extremely important because, and that is the reason why we are getting, a fair share of candidates with more than 15 years of experience. The reason is this, that, across organizations, now the imperative is towards finding value and deriving value from, AI and machine learning, and how this can be applied either to service clients or internally within existing businesses. Now, if you are going to take charge of that initiative, or if you have to have any role to play in that initiative, you cannot have a superficial understanding. Because if you have a superficial understanding, if you don't have the depth, you may not be implementing these things, but if you don't have the depth to understand what all is possible and how should you lead your teams, then you will always be on the periphery of this new change that is happening in your organization. So if you want to have a role to play in actually driving growth for your organization as well as yourself, then I think it is important that your knowledge doesn't get restricted or constrained, and it doesn't stay superficial. Sandeep, your question is that how do we pick industry experts who come and teach? So Sandeep, we have a very rigorous selection process towards who comes and teaches, and there are multiple demo sessions that happen even before they come to the classroom. And usually all these experts are actually industry practitioners. So because the expectation is that they'll come to the classroom and they will um, you know help candidates appreciate what is happening in the industry in these areas. Debobrata, I believe you are a professional with experience in .NET, and you are wondering whether you should move, or you should try and move into ML or data science. Absolutely, Debobrata. I don't think .NET has the kind of demand that it was having a decade or so back. And if you get stuck in .NET, then that is a technology that is not driving the future, right? Hence, it is important that you reshape and upskill yourself to move into a technology that is actually driving the future, so that you have better career prospects going forward. I also have a few questions around the format of the program. So the format of the program, as I mentioned, is one weekend every month. So the first month it would be a Friday, Saturday, Sunday, one Friday, Saturday, Sunday. The next month it'd be a Saturday, Sunday. The third month it'd be a Friday, Saturday, Sunday. So like that, it keeps alternating. Overall, across, if you choose to do only the ML program, then that would be overall about 15 days of classroom sessions, amounting to about 120 hours of classroom interaction. And if you choose to do the AI as well, which is AI and machine learning, then that would be about 30 days of classroom programs in 12 months, amounting to about 240 hours. So I have also a couple of questions around transitions that happen for senior professionals. So the transitions that happen, especially at an experience range of 12 years and above, what we see most commonly is that these transitions happen, when you have opportunities or projects coming up within your own organizations and you get a role to play in leading those. At less than 10, of course, there are plenty of examples where candidates also move across companies, and that is very much possible, given, especially if you have domain knowledge and now you learn machine learning. So that is a very potent combination. But at senior levels, 15 and above, 15 years of experience and above, there are a fair amount of transitions. In fact, a lot of transitions that happen within the organization where candidates get to lead newer projects, newer deliveries, newer clients, newer engagements, and so on. Balasubramani, your question is that is ML applicable for machine learning? Absolutely. Sorry, is ML applicable for manufacturing? Absolutely. In fact, increasingly with every batch, we are seeing more and more candidates coming in from manufacturing. This was an observation that I was making earlier as well to somebody else, is that when we look at automobile industry itself, the candidates coming in from automobile industry into our machine learning, data science, and AI programs have actually doubled in the last 6 months because of the kind of applications that are happening there. There are a few questions around what would be the average time per week that is required to commit to the program. So we typically expect our learners to commit about 5 to 6 hours every week in a dedicated, concerted fashion throughout the course of the program. And this is beyond classroom hours. That 5 to 6 hours is needed for self-learning, for assignments, for projects, and reading up even more. Faculty will give you a lot more work to do, so you'll have to do all that work, and that will take that kind of time. As long as you stay committed to the course and do this week on week, spend this 5 to 6 hours week on week, I think you'll be in very good shape and you'll be able to learn very well. Problem happens when that discipline is not there, and let's say for 3 weeks you don't do anything, and the fourth week you suddenly try and learn for 20 hours. That becomes a problem, because that you can't learn these things uh, in that kind of a fashion. All right, I think I have answered most of the questions here. The questions that I've not been able to take up, I'll also request the admissions team to reach out to each of you and see if you have any further queries. I have also mentioned my email ID here. Feel free to write into me. I'd be more than happy to help you out. I've also mentioned the contact details for the admissions office, so you could reach out to them as well, and they would be able to help you out as well. Once again, thank you so much for joining me. It was wonderful interacting with all of you, and I hope you found the session meaningful and helpful. I would love to hear some feedback so that we can make this better, as we go along. Once again, thank you for your time and interest in machine learning, and I wish you the very best.